My name is Prima Roman, and I'm a distributed systems engineer at Rotational Labs. And I've been a data professional for throughout my career. I started out as a data analyst, and then I became an engineer building data products and software applications. And then about 10 years ago, I developed an interest in machine learning, and subsequently worked on several machine learning projects where I was responsible for deploying machine learning models. And so it's my pleasure and honor to introduce you to today's speaker, Dr. Rebecca Bilbrow. Dr. Rebecca Bilbrow is a machine learning expert with a deep knowledge and understanding of all machine learning concepts. And some of you may have seen her imparting her knowledge in LinkedIn through her data science tip of the day videos. She is the author of a O'Reilly book on natural language processing called Applied Text Analysis in Python. She is the creator of the popular open source machine learning visualization library called Yellowbrick. She is a faculty member of the Georgetown University Data Science certificate program, and she's also the CTO of Rotational Labs. And suffice to say, you are in for an amazing webinar. And with that, I will pass it over to Rebecca. And actually, before we get started, just wanted to let you know that we're going to be taking questions at the very end, but you can use the Q&A feature or the chat feature to pose your questions, and then we'll leave some room at the end to answer your questions. So go ahead, Rebecca, take it away.
Thank you so much, Prima, and thank you to everybody who has joined. I know a lot of you are people that I sort of reached out to, and invited personally because I, kind of noticed the stuff that you're working on, and it seems like it might be related to the stuff that I'm working on, and I'm excited to find you all and kind of build this community of people who are working on these kinds of real-time projects and trying to just create more open source packages in this world, and more energy and kind of more collaboration, because I think that we are those of us who are kind of part of this community of doing streaming analytics. I think we might be onto something kind of new that other people haven't really figured out yet. And so that can be really exciting. And I think a lot of us are really excited, which is why you're here, why you're listening to this webinar. But it's also a little bit scary because when you're not seeing, other people talking about this, it can cause you to maybe question, what am I doing? Am I like way too far advanced or into the future? But I think that the goal today is to convince you that this is real, that this is something that's like really can be super practical. Like you can use these kinds of techniques to do a lot of complex things, but you can also use them to do kind of really straightforward analytics that can kind of start delivering value at your organization, like right away, without months of model training or any of those things that we've sort of been conditioned to believe is sort of the natural precursor to any deliverable in the data science space. So I'm hoping I'll be able to convince you all of that. So let's build an end-to-end live analytics application together. So I'm going to kind of skip over this slide because Prima, thank you so much for that introduction. I don't really feel like I need to say any of this, but maybe I'll do like a wave so that you recognize who I am from my videos. But you'll get all of these slides tomorrow. Everybody who's on this call who's registered, you'll get these slides. And if you want to click on any of these things to learn a little bit more about me and what I do, you're welcome to. So by the end of this tutorial, you're going to be able to build a real-time analytics application. You'll be able to use Python, Ensign, and any of the kind of open data sets that are here on the data playground in this kind of image. On the right-hand side of my screen. I'm going to kind of focus on the earthquakes one just because that seemed like an interesting place to start. And we heard Taylor Swift fans were creating seismic activity. And so it seemed kind of delicious to be able to take advantage of this data set that we have made available on the playground. So everything, all of this is, free. You don't have to pay for anything. This can just be like a tinkering project that you experiment with. But there's really kind of a lot that you can do with just, a few things. So I'll show you how to quickly set up like a quick Ensign account, which you need in order to get API keys to interact with Ensign. We'll talk about where to put those API keys. I'll give you a kind of a 5-minute intro to the PyEnsign API, and then we'll talk about architecting an event-driven data science project. I suspect that that's probably the part that keeps most people, that blocks most people from moving forward in this kind of endeavor, right? It's just too hard to imagine like what the architecture of the project will be. So I'm going to try to slow down at that part and really focus on kind of showing you how I architect these kinds of solutions. And honestly, like it's like whiteboard sketching. A lot of the times it's not very fancy, but if you can kind of draw a picture, it starts to unlock some of the things that you maybe don't know as well as you want to know. And then you can say, okay, I need to learn a little bit more about X, Y, Z. And you can kind of focus in a little bit more so you know how to move forward. I'll show you kind of how you would use this code to do data ingestion and also to do analysis. And then I'll give you a few ideas for what you could do next. So let's get started. So the very first step is you want to create your Ensign account. You're going to go to rotational.app/register, and you'll get taken to this form. You'll sort of fill in the obvious stuff first, your name, your email, you'll create a password. But keep in mind that even though you're going to sort of start out just tinkering on Ensign, you're going to use a free account, and you could always use that, in perpetuity. But really, I think where Ensign shines is when you can collaborate with other people. And so one of the things that you should do also is you should create an organization. This could be like the team that you work with at work, or like the name of your organization at your company, or whatever you want it to be. But you want to kind of be thinking that, you're going to build something great just by yourself in a couple of hours, maybe like a day or two. And then you're probably going to want to share it with somebody at work. So to kind of make that easier later, go ahead and sort of create your organization, and that will get everything set up so that when you want to share this, you can share this with people at work and they can start adding on to it and kind of building out some of the other parts of the pipeline that maybe aren't your wheelhouse or that you just can't do because you are a busy person, I imagine. So step 2 is you want to create a project. And in event-driven land, in kind of a stream land, you should think about, when you hear the word project, you should think about database, right? So the reason that you create a new database is you have some new use case, and potentially some of you work at large organizations where all of the databases that are in use are things that have been in use for decades. But it can be useful to introduce occasionally a new database just to do, let's say, documents. So let's say you have Oracle and it's serving you very well. It's extremely high performance, like transactional database that allows you to kind of manage your customers. And you don't need to replace that, that's fine. But sometimes it's helpful to add on another small database, maybe a document store, something that's set up to, it's like a vector database. Let's say if you're doing vector machine learning a lot, it can be helpful to be able to spin up for a specific use case, like a side database, and then you can figure out how to get your databases communicating. But for this project, let's say we're gonna, this is gonna be about earthquakes, but the point of the project is not to understand earthquakes, right? It's understanding the impact of earthquakes on, let's say, the supply chain or our freight operations, right? It's going to prevent our truckers from driving across state if there's a disturbance, right? So kind of maybe go up just one level from your first instinct of what to name the project and pick kind of, well, what is the problem that we're solving, right? What's the use case? And that's how I like to name my projects. It helps me remember what the goal is. So now we've created the account, we've created the project. Next step is to create and store your API keys. And so you're going to get to a screen in the UI that asks you to create role-based access keys. This is mainly so that you can control who can write and read data, just like in a traditional database with role-based access. So it's very similar to IAM. We've tried to make it easy, so you can either say like, just give me keys that have full access, or you can kind of pick and choose. Since this is something you're just going to start experimenting with, you can kind of start by creating a full access key that will allow both reading and writing. So both the publishers need to write, subscribers need to read. We're going to be using that pub sub model. So in the beginning, you can just kind of create like these full access keys, and then you can delete them later and create more specific keys, when you kind of move towards the deployment process. Okay, so this is something that I think is not really taught in most data science education programs. So if this is something that you already know, you can just like skip forward like a couple of minutes. But if you are a data scientist and you have not been kind of educated about like your environment or environment variables or how to store things in your environment variables, this is worth figuring out. Like it'll probably take you maybe 30 minutes to an hour, of time kind of figuring out what you need to do based on your specific operating system. But I promise you that is really going to pay dividends. Because it's going to protect you from doing things like accidentally, submitting keys to GitHub and getting in trouble at work and stuff like that. So it is worth it to kind of figure this out, but kind of keep in mind that it might look a little bit different. So I kind of gave you a few different snapshots of what it might look like for you specifically with your computer as you're trying to add your new API keys as environment variables. I've also included in the slide deck that you'll get tomorrow, some links depending on different operating systems. I also have one of my videos that kind of talks about what environment variables are and how to think about them and how they'll help you. Worth investing a little bit of time figuring this out so that you can store API keys, all API keys, and then specifically your Ensign API keys. Okay, so let's assume that you've kind of figured that out. Let's do a quick introduction to PyEnsign. So PyEnsign is, as you probably are already assuming, it is the Python library that interacts with the Ensign streaming database platform. And you can just pip install it like anything else. It is, it has some dependencies that might be a little bit new to you, specifically gRPC and protobuf might be a little bit new to you. If you're curious to learn more about gRPC and protocol buffers, let me know, send me a note. We have a blog post that we posted like maybe a year or two ago that's kind of like an introduction to protocol buffers if you're a data scientist, that might be helpful. But just kind of, you don't really have to understand that in order to use PyEnsign, but if you're curious, let me know and I'll send you some extra credit resources. But really all you have to do is pip install PyEnsign. So there's three things you got to know about the PyEnsign API. So the first thing is you have to understand what it means to publish. So kind of whenever you say the word publish or write the word publish, kind of think about like a loudspeaker, right? So we're kind of sending out a message. It might go to just one person who's listening, or one subscriber who's listening, or it might go out to potentially many. That's kind of where you get your scaling later on. Like if your DevOps team is asking you how this is going to work, we're using the pub sub model, which means that scaling is sort of a built-in part of the architecture. But in the beginning, if you're just tinkering, all you need to do is publish, to one subscriber. You need one publisher, one subscriber to kind of get your end-to-end process going. So the publisher's job is to write events. So it's just like, it's like in a traditional relational database where you have tables. In streaming land, instead of tables, we have topics, and instead of kind of picturing like a rectangular table with a bunch of rows and a bunch of columns, the topic is a bunch of changes to objects over time. So it's kind of, you can turn it into a table if you need to, but you can also look for, oh, this row changed, on this date, it went from this value to this value. And so you can do a lot of kind of really fine-grained real-time analytics using topics that you can't do with like a traditional relational table alone. So the publisher's job is to write events. It's going to add new stuff to the topic. Subscriber's job is to read events. Just like in a traditional relational table, just going to read events off the table, except we're not reading, rows, we're reading events, so changes over time. And that's kind of where the real-time analytics starts to come in. So then we've got our kind of notion of publish, our notion of subscribe, and the connective tissue between publish and subscribe is a topic. And the way that you're going to interact with all three of these is using a client. So the first step is to create a client, because in order to publish, in order to check if a topic exists, in order to subscribe, you need a client. So what is a client? Great question. I'm so glad you asked that question. A client is an open connection to the database, right? And you actually probably have a lot of experience creating clients. Maybe you don't think of it that way. Maybe you think of it as a connection string or something like that. But basically a connection, a client, some kind of open connection to a database that is the connection that allows you to do things like writing to the database or reading from the database. So this is why you need your API keys. A few slides ago, I was talking about make sure you've got API keys. That's kind of the first step. It's because, Ensign is going to look for your environment variables, look for these API keys when you create your client. So you're going to say from PyEnsign.Ensign, import Ensign, and then you're going to say client equals Ensign. And if you don't put anything inside the parentheses, Ensign is going to look in your environment variables. And it probably does this for a lot of the database interactions that you do kind of regularly on things like Databricks and stuff like that. It sort of knows that you have kind of in your virtual machine or on your local machine, you have these values that your operating system is aware of, and it can go look for them, but it's not going to show them. It's not going to get them kind of hard-coded into your code, which is a much safer way to be using passwords and API secrets and tokens and stuff like that. But if you would prefer to manually supply your API keys, let's say you haven't quite figured out how to store your API keys yet, and you just want to do a little bit of tinkering, you can also pass them in as arguments, right? So instead of saying client equals Ensign with nothing in the call, you can say client equals Ensign, and you can pass in client underscore ID and client underscore secret. And those are the two components of your API keys that you will need. And once you've got a client, you can do all the things that we were just talking about. You're going to be able to call client.publish. You're going to be able to call client.ensure topic exists to make sure the topic is ready. And you're going to be able to call client.subscribe. So that's what we're going to do. So next is, how do we publish? We're going to use client.publish or ensign.publish to publish events to a topic. And so the syntax you can kind of see here in this code snippet where, generally you'll create an event and you want to kind of format that event. I'll talk about that in just a second, but you kind of create the event. And then in order to publish that event, all you have to do is say client.publish, and then you pass in the name of the topic or the table, right, that you want to publish to, and then whatever the event is. And you can pass in multiple events if you want to. The only thing that might look a little bit unfamiliar to some people is the await syntax here. And you're going to see that a little bit in this code. If you are new to asynchronous programming, we did do a webinar, I think a month or two ago, on asynchronous data science. We also have a blog post on kind of the async programming patterns. I think it's something that most data scientists probably have never really tinkered with. So if you haven't, you're not behind or anything. I think this is just, it hasn't been something that people have been kind of focused on in mass in the data science community. So you get to be some of the first people to be using the async package, which has been around for a while, but to use it for doing real-time analytics is kind of a new and very exciting use case, I think. So I told you I would say a little bit about what an event is, and we are going to come back to this in a little bit more depth. But at a very high level, an event contains kind of two things. It contains data, which in this case, we're sort of using a weather example in this code. So maybe that's things like whatever the current temperature is at that exact moment in time and whatever the units are. Here, the temperature where I am is 105 degrees and there's a heat warning. So 72 degrees Fahrenheit sounds really temperate and nice to me. That would be very nice. So, kind of that first part of the event is the data itself. And the second part of the event is the type. And, if you've never heard of the expression MIME type, that, might be a good thing to Google and read up on a little bit. We also have some, there's some documentation in the Ensign docs about different types that you might want to check out. But basically, you should think about this as like, this is the signal to the subscriber about how they should read the event that you want to send them. And so as a publisher, it's in your best interest to make the events as easy to read for the downstream subscriber as possible. And one thing that makes it much easier to read is to tell them what type of data you're going to send them. Because in theory, you could kind of send them anything, right? You could send them JSON, but you could send them text, you could send them images, you could send them pickles, like, serialized machine learning models. You can kind of send them anything. And you can even send mixed types on the same topic if you want. But, as we'll sort of see a little bit more in detail later, there's sort of like what's possible, and then there's kind of what's going to be compatible with the people who are receiving the data on the other end, and that might be you, that might be somebody else on your team. But we want to try to be as accessible as possible with our data, which means we're going to kind of tell you in the event what the data is and also how to read that data, which is the MIME type. Okay, how about on the other end, subscribing to a topic? So in order to subscribe, the syntax is sort of that same ensign.subscribe or client.subscribe. And inside the parentheses, just as we did with publish, with subscribe, we're going to pass in the name of the topic or the ID of the topic that you want to listen to. And it can be multiple topics, right? So you can say, well, I want to listen to both of these things because whatever analytics I'm doing needs to take into account two different live feeds and then figure out how to, do something to them together, to deliver kind of some meaningful analytic result. So you can, kind of have multiple topics here if you need to. You'll see, again, this sort of async syntax, which, I know that might be a little bit new, but this is, this is one of the ways that you can achieve that kind of real-time live analytics using just Python, which I think is incredibly satisfying. If other folks out there who are big fans of Python like I am, it's really exciting. The idea that you can do all of this and you don't have to program in Java, you don't have to do it in C, like you can leverage all of these really sophisticated techniques like asynchronous programming just with Python. And you can print out events. So if you actually want to inspect them, you can print out events and it'll look something like this. It'll tell you, it'll have kind of the ID of the event. That's really important because one of the cool things that Ensign does is it can do automated deduplication, which is super useful for the work that I do, because I frequently have to, as you'll see in this example, I have to set up a stream that's continuously pinging some sort of REST API, like a data API. And a lot of times I'm getting repeat values. And I don't need to save all of those repeat values, but I need to get all the new ones. And so the cool thing about Ensign is that you can kind of allow it to do the deduplication for you. If it sort of hashes together all of the values and determines that this is the same data that you've already ingested, it'll kind of leave a little marker there, but it'll allow you to kind of skip through it when it gets to the query time. So you don't have to do all of that kind of like pandas.deduplicate stuff. From the subscriber perspective, that can already be handled for you, which I think is incredibly convenient for a lot of the work that I do. So this is kind of what maybe an example event might look like for, let's say, weather data that you're ingesting. Okay, so let's see, time check, 12:27. Okay, so I think that we're doing fairly well on timing. This is the part that I sort of said at the beginning. I think this is the hard part, like figuring out the asynchronous programming is a little bit of work. If you aren't familiar with environment variables, kind of figuring out how to store your environment variables securely, that's a little bit of work. So that's definitely an investment. But I would say, if you want to get really good at doing the kind of stuff that I do, like the sort of real-time analytics, the main thing you want to practice is this part, the architecture part. Because once you sort of develop an intuition about how to build and architect these systems, a lot of the code is sort of just the same every time. There's a lot of kind of templating you can do. You can really accelerate development. You can kind of do scaling, as I said. A lot of stuff is built in for you. So it's really, the trick is to kind of figure out how to get good at the architecture part. So I'm going to walk you through like a real example of me trying to architect something so you can sort of see what my process is. So here's a hypothetical use case, right, where we are, we're interested in earthquakes, but we have a reason that we're interested in earthquakes. And it's because earthquakes and other kind of natural disasters have an impact on the supply chain, and they can endanger the supply chain. There's a lot of like places where people are manufacturing things where just a little bit of disruption, can cause a little laser to slip. And, there's a lot of things that can go wrong, even with very minor disruptions. And it's very useful to be able to anticipate those. So you can say, okay, well, don't do the laser right now, because we know that there's seismic activity that's detected, around this facility. So here's kind of my, imagined use case where, we want to use the existing USGS, United States Geological Survey REST API. And like I said, we're going to kind of come up with a cadence where we can ping it and ask for any new earthquake updates. And so what we'll end up with is a topic over time that just kind of gets added to, that shows us, every time there's a new seismic event detected. And then on the other side, we're going to have a subscriber that is reading off of that topic of all of the things that happen over time. And it's where we kind of embed the analytics. So, like kind of looking for certain values or certain locations, or sort of running things against a model. That's kind of where that's going to happen. So this is kind of a sort of imagined use case. So let's dive into how I would sort of start designing this. There's a couple of steps that I find that I follow basically every single time. And so I tried to write out what I do. The first step is this sort of data flow architecture. On the left hand of the whiteboard, I usually write out, okay, what are my data sources? Or what does my input look like? And then on the right hand side of the screen, I say, okay, what does the output need to be in production? And that could just be some kind of data that's in the database that can be queried. But oftentimes it's even a little bit more than that. It's like a dashboard, or it's a model store or model registry or something like that, that also needs to, there are a few outputs. So kind of thinking through the inputs that I need to deal with on the left-hand side of the screen and what the desired outputs are on the right-hand side. And then everything else is like figuring out how to connect those things up so that they all get updated as quickly as possible. And that's really, that's the trick, is figuring out how to leverage the sort of real-time design patterns so that there's not these sort of delays in updates like, oh, we have to update this first, and this we can update next week. But those things that sort of slow us down, I think, are actually not necessary a lot of the time if we can kind of start with this, design architecture early on. And the interesting thing is like, this is not something that I learned when I was learning data science. It's not even something that I've necessarily taught before today. So I'm not sure what other people are doing who are kind of successfully doing real-time analytics. But I think one thing that's really interesting is that when you are a data scientist doing this activity, I think the results are really different from when a data engineer does this activity, because they have such different perspectives of what the output should be. They're thinking about different parts of the application. And so this can be like a useful time to maybe bring in a few people from your team to whiteboard or spitball together, because there are going to be different perspectives depending on people's experience producing and consuming data. Okay. Second step is that we want to figure out what the event handlers are. So these are, and you'll see in a diagram in just a moment. Basically, these are the things that are going to take data from one state and turn it into something else. And so I'm calling that a handler to be sort of as flexible, like it's a very flexible definition, because it could be a lot of different things. The next step is, once we know the event handlers, we identify the topics that are necessary that will power those handlers. And then finally, we're going to design our event schema. And that's going to make sure that we have all of the features that we need for analytics. But your data engineers or your ML ops team or your platform team might also want to weigh in a little bit on the event schema, because they might be interested in some of the metadata kind of for other purposes. But if you're the data scientist and you're designing the event schema, at the very least, you can ensure that the features that are there are the ones that you need to do the analytics or the machine learning that you want to do. Okay, so this is usually how it starts. I'll have kind of a whiteboard and I'm just writing on it, and you can see my handwriting is not amazing. So this is me being very vulnerable. This is how I architect real-time analytics. What are the data sources? Okay, in this case, it's a RESTful API. I say the endpoint here, it's very small text, but you can see kind of what this earthquake endpoint is going to be that we're going to be hitting on the right-hand side. Okay, let's say we need some kind of dashboard and we want to be able to geolocate seismic activity to help anticipate shipping delays, let's say. So then the next step here is that we're going to determine what the event handlers are. So our first one is we need some kind of handler that can continually ping the API and write all of the events to a new topic. And then the second handler we have is going to read off of that topic, and it's going to perform real-time analytics and maybe modeling, or potentially it's going to even do training eventually. We'll kind of leave that to the next webinar. So if you are interested in the real-time inference, you should check out the next webinar that we're giving in a couple of weeks. And I'll share a link to that at the end of the slide deck. And then the next step is to figure out what the topics are going to be. So we need the earthquakes topic, which is kind of the raw seismic activity. And that's going to allow the first event handler to communicate with the second event handler. So the first one is going to publish to that earthquake topic, and the second one is going to subscribe to the topic. That's how they're going to asynchronously communicate with each other. And then we need at least one other topic, which is going to be the model topic. So that's going to be where we are either, it kind of depends on the use case, but there might actually be multiple things that the second handler is doing. It might be, it might subscribe to the earthquake topic, and it might publish to a model topic if it's updating that model in real time. Let's say it's some kind of real-time machine learning model. And actually, Prima just had a great blog post that got posted last week about 2 libraries that you should check out if you want to look at how to do real-time machine learning. So River and Vopal Wabbit are 2 open source Python libraries that you can check out. So let's say maybe you're generating real-time predictions on one topic, and maybe you're retraining or updating a model in real time on a separate topic. So you kind of identify what those topic streams are. And now we're going to talk a little bit about best practices for creating topics. So as I said in the beginning, like a topic is just basically like a table in a traditional database, except that you can capture all of the changes to all of the rows in that table over time. Usually when you query a table, you get a snapshot, like this is what's true today. But if you're training a model based on a snapshot, like if the snapshot is from today, that's maybe okay. But then the model that you train, if you're trying to use it in 2 months, like the table probably has changed since then. And so kind of being able to train models based on topics is a way to make sure that it's continually tailoring itself. The model is continually tailoring itself to new data as it comes in, rather than being trained on kind of old snapshots. One of my favorite tips is to think about how it's going to feel when you have to query this topic later, right? And you can actually just use like SQL type syntax to query your topics. So it's going to look something like select distinct location from earthquake reports where timestamp is less than something, right? So, kind of that. So think about, I'm going to have to type this topic in every time I want to do a query. So, think about that. So you don't want to make it so long that it's going to be, like really annoying to have to type in a really long topic name. But the flip side of that is that sometimes it is very useful to encode the data type into the topic. So, maybe earthquake reports is a good topic, but if you're ingesting data of a lot of different types, you might err on the side of naming it earthquake reports JSON so that all of your subscribers know that they're going to be getting JSON data, which helps with decoding. So a couple of things to think about. Step 4 is designing your events. And I always say, like, when you design events, this is where empathy is required, right? Because events have to be something that is like mutually meaningful, both to the person who's doing the ETL or the team that's doing the ETL and the team that's doing the analytics. And that's tricky. It's tricky to figure out how to agree, especially if you work in different departments at your organization. And so I'm not going to trivialize that. I think one of the best strategies as a data scientist is just getting good at empathy, getting good at like just going over and knocking on the door or the virtual door and saying, hey, like, I'd love to learn a little bit more about what you do, because building those networks, those pathways allows you to build like way better stuff, because you can kind of get people in a room and say, like, what should we put on this topic? What should these events look like so that they satisfy everyone? But here's kind of an example, for our earthquake use case. Let's say, we're going to design our event so that it contains, a certain number of things. It's going to, contain probably the things that are most critical: the magnitude of the earthquake, the location where it happened, the time that it happened, and then maybe also some sort of metadata, like when the article was last updated, and if you want details, the article linked, and a couple of other types of data points. Okay, so we've got about 20 minutes left. So with that time, I am going to show you that actually most of that stuff that we just talked about, that architecture step, is actually kind of done for you. If you are interested in using the data playground, you can kind of leverage a lot of code that we've already written that's sort of like example code. And so I'm going to show you one example, but I would encourage you to check out the data playground and kind of play around with some of these other data sets if they're more relevant to what you do. So go ahead and go to rotational.io/data-playground and click on the earthquake alerts data set. And then you're going to click this little getting started button up in the right-hand corner. And it's going to take you to the repository. Would love to have you star this repository, by the way, if anybody is interested. It's pretty new, so getting some support from the community would be wonderful. So kind of check this out, give us a little star on this data playground repo on GitHub. But you can navigate to the Python example, and all you have to do is clone this locally and install the requirements using pip-r pip-install-r requirements.txt. And once you've done that, you can basically run the ingestion all by yourself. So what you need is 2 different terminals. So this assumes that you've already cloned the repo, installed the requirements. So in one terminal, you're going to run Python subscriber.py, and I'll show you what's in that file in just a sec. But you're going to run the subscriber, and then in a separate terminal, because the subscriber is going to run, and it's just going to wait. So it's going to look like nothing is happening, but that's how asynchronous stuff works, right? So the subscriber basically picks up the phone on its side, and it's just waiting for something to happen. And so it's gonna wait there for you. And then in another terminal, you're going to start the publisher. You're going to run Python publisher.py. And that's when stuff is going to happen. And so really quickly, you're going to see both terminals get filled up with events. So from the perspective of the subscriber, it's going to say, I just got a new earthquake report. The magnitude is 1.8 or whatever it is. It'll be live data for you. And the publisher is going to say, just found something and committed it, just found something and committed it. And so it's going to tell you like that stuff is happening. That's how you'll know that it's working. So really quickly, just to kind of situate the code that we're providing in the data playground with that sort of idea of the publish subscribe API, this is where publishing is happening, right? So there's a publisher.py in that code repository that contains this class called the earthquake publisher. And inside the earthquake publisher, there's a method called recv and publish. And inside there is a call to self.ensign.publish, which is just the client.publish, where self.ensign is the client stored on the class. And then on the subscribe side, so if you dive into subscriber.py, that file, you're going to find this class, the earthquake subscriber. And similarly, it's got this function called subscribe. And inside that subscribe function, it's calling self.ensign.subscribe and passing in the topic ID. So that's how everything is working. That's how it maps back to the API that we talked about. And now here's how we get the analytics in. So the analytics are in this case are going into the subscriber, right? So the subscriber is going to get a new event and it wants to do analysis right away. And so you can do things like add a function, something like detect emergencies, let's say. And emergencies are anything that have a magnitude that's greater than whatever threshold you set it at, right? So for you, it might be 3.4. For me, it might be 5.6. So you can kind of set your own threshold. In this case, it's set to 4.2. And this will ensure that events are getting flagged if they exceed that magnitude threshold right away, instantly, without any delay. But you can kind of see how this pattern would allow you to start to do more sophisticated stuff, where you can use that same pattern to do real-time machine learning too. And like I said, if you want to figure out the how to do real-time model inference, that's our next tutorial. So I won't give away too many spoilers there, but you can kind of fit it in the same way here into your subscriber, sort of embedding it into your subscriber. And then once you've got pub sub set up, it'll just happen as soon as any event comes through that the subscriber detects. So in terms of next steps, I know we're running a little short on time. So what I will say is I think that the best thing to do next is if you decide to kind of clone this and play around with it, I would suggest building a very quick and dirty prototype of a dashboard using something, let's say Grafana and Prometheus. I actually know somebody who is on the call now, Parth. I don't know if you're there, but Parth actually is working on, one of our community members is working on something like this. And is doing kind of geo visualization. So I don't know, Parth, if you're willing to share the link to your repository that you've been working on. He's got these like really fantastic geo visualizations of earthquake data. So definitely check that out. Parth, if you're willing to share, sorry to call you out. Hopefully I didn't embarrass you, but it's really, really excellent project. And that's a way that you can start to do things like geo-position these events, co-locate them with other data at your organization that's important so that you can detect problems like instantly. If you want to add teammates to collaborate, you're going to go back to the UI, go to the team tab, and you can add team members here. Make sure that they create their own API keys. You can check out the playground. There's a bunch more data sources, stock market, weather, and you can kind of play around with stuff. We've got more examples that you can check out, and we've got developer docs that we keep up to date and try to make them really accessible. And kind of meet you where you are as a data scientist rather than trying to make you turn yourself into a DevOps engineer or something that you're not. And I hope that you will join us for the next tutorial, which is on September 5th. And like I said, that one is going to be on kind of shifting from just real-time analytics to thinking about real-time model inference. And I think it's going to be really exciting. So thank you so much. I would love to hear if anybody wants to tinker with the data playground, please reach out to me. You can email the support at rotational.io, but you can also just email me or message me anytime. I would love to hear what you're using the playground for. And it'd be great to hear from you anytime. Thank you all so much for putting an hour aside today to explore this topic with me. I think it's really important, and I'm really excited that there are other people out there who are getting excited about real-time analytics and real-time data science and machine learning together with me. So it feels good to be surrounded virtually by other people who are excited about the same stuff, and I'm happy to take questions now.
Yeah, thank you so much, Rebecca, for the tutorial. So we do have a few questions here, and then anybody else who has more questions, please go ahead and use the Q&A and the chat feature. So one of the questions was basically this participant is interested in finding out like what tools do you ordinarily use to visualize data flow architecture for various stakeholders?
Oh, that is such a great question. So I'm one of the only thing that I really miss about being kind of in-person work, when we all used to work in offices long ago, I miss the whiteboards, and I miss getting to like go into a room with a group of people and actually draw on a whiteboard together. I think that is my #1 choice, if that's possible. But that's just not realistic. That's not really where most teams are right now. A lot of us are remote. And so I've been experimenting with using Google Jam sessions. They sort of just, if you have like a Google Workspace account, they're built in. But there's a lot of tools like that. Honestly, you could just use paper, right? Like it doesn't really need to be fancy. It needs to help you think through all of those steps that you're used to maybe skipping over because you're like, I'm a data scientist. I don't really need to think about that. So it's sort of it's a way to challenge yourself to kind of do the work and say, okay, well, all right, well, in order to get this, I'm going to have to do this over here on this side, and kind of make sure that you're connecting the dots. So I don't really know if the tool matters, but I've had kind of fairly good luck with kind of the Jam boards that come built in with Google Meetings.
Great. It's another question. I'm not sure if you might have the answer to this, but one of the participants was interested specifically in mental health data and if there might be any like real-time mental health data sources that are available.
Wow, that is a great question. I don't know the answer, but I would love to actually, one of my teammates is on the call, Becky. Becky, if you could create a reminder for me to look into that, because I think that that's a great suggestion for another data set that we could add. You know, and it might be also just a good opportunity to talk about how to do things like, you know, encryption and anonymization in real-time data. You know, I think probably any open data set that has mental health data is already going to be anonymized, I'm sure. But, you know, it's something that, you know, if you work with health data, which I do and have since the beginning of my career, there's lots of kinds of data that, you know, you need to be really careful about when you're passing it around between publishers and subscribers. And if there are private details, then you want to make sure that they're either anonymized, you know, or very early on, or potentially encrypted, so that in order to read it on the other end, you have to know how to decrypt it, or you can kind of use API keys to make sure that the people who are accessing that data are the people who should access it, and that you can revoke API keys, you know, right away if you need to make sure somebody no longer has access. But yeah, mental health data is a great suggestion. I had somebody from the community suggest a powerlifting data set to me 2 weeks ago. So she's a professional powerlifter, and she showed me this kind of massive data set of powerlifting competitions all over the world. And you know, I thought that would be a fascinating one, but mental health is a great suggestion, and we can definitely take a look. And if we find anything, we'll let you know.
Great. So there's a coding related question. I think this might be worthwhile kind of expanding on, but the subscribe method, can it take as many arguments as one wishes? And I think there's like also like we have an outside like subscribe method, but then there's also the Ensign client.subscribe. It might be worthwhile kind of going over the difference between the two.
Yeah, so that's a very good question. I think that, you know, when you are just getting started, I would encourage you to kind of look at to not dive in right away to the protocol buffers, although you can look at the protocol buffers. Those do actually describe how subscription is happening directly on the Ensign stream, so you can see how the RPC is actually working. That was, you know, I referred to gRPC and protocol buffers as something that, you know, might be tangentially interesting to some people. So that is kind of how, you know, if you want to really deeply understand how subscription is happening, you know, this code is all open source, and you can take a look at it. But I will say that in terms of the client level subscribe method, you know, there is, you know, if you need many topics, let's say you need to be listening on 10 topics or 30 topics at the same time, that is totally feasible, right? So, and I think actually as as you start to design more elaborate and more complex solutions, you probably will start to notice that the handlers that you're writing have many subscribers and potentially many publishers, and kind of realizing that like, oh, we don't actually have to wait to do this. We could do this thing right away. And I think that is, I'm hoping that really frees up your minds to think about, like, there are lots of ways that real-time can kind of benefit things, making sure that different sources are updated, at the same time. Has anybody ever been like in an airport and you're looking at the terminal, like the posted flight information, and it says something like your flight is on time, but then you look on your phone and it says that it's canceled or something, or it's delayed? That irritates me so much, because when you know how to build these kind of real-time streams, there's no reason that those two things should be different, right? Because whatever is emitting the event that says a cancellation has happened, it should go both places, right? There's no reason to send it in an order, right? And so there's all kinds of things like that. So I guess, I don't know if this, totally answers the question, but yes, like you can definitely, publish multiple things, subscribe to multiple topics simultaneously. And it's a good idea. It's a good idea to do that.
Great. So another question was, I'm assuming, I guess this question about like, can this be presented in my company? So are we kind of like, for the person who asked the question, you're kind of asking like if we could do something like this presented specifically within your company?
Sure. I mean, hopefully you can tell I like doing this stuff. I'm not a full-time TikTok creator. I do I do write code and work. But like this is what I love doing, right? I love talking to other people who are excited about the real-time analytics stuff. And I think it's, one of my very favorite things is talking to domain experts who just really deeply understand their data, and kind of brainstorming together with like some domain experts about, like kind of building out one of those architecture flow diagrams, talking to kind of experts or giving kind of a version of this talk to a bunch of domain experts at a company, I think would be a great opportunity. And I would love to do that. So yeah, reach out and let us know.
Awesome. And there's one, this is not a question, but a comment, but I think this is a really great idea about having a session on how to handle PII or there's similar challenges with, with data sets around modeling data flows.
I mean, that is like, I think that is a fantastic idea. Kind of thinking about maybe even some different maybe like PII postures where you have to kind of be able to do erasure all the way to being able to do like fakerizing values or real-time anonymization, because there's a lot of really helpful patterns that I've used, and the pub/sub model really makes them so much easier, right? Like you don't end up with a bunch of private data that's like tech debt that's weighing on you that you're like, oh, I really need to go through that and clean it up because we're going to get in trouble, or we haven't done a batch job in a month. So there's a month's worth of private data that's like sitting around. And if somebody hacked it, we'd be in big trouble. Like it's such a peace of mind to kind of know that this stuff is happening as soon as it flows into your system. So you don't like sit around with that fear that you're like a month out of date with your PII treatment or GDPR, right? So I think that's a great suggestion. I think that we will definitely do a follow-up on that.
Awesome. So I think we are kind of at time here, and I think this is a great webinar. And I think for all the people who are participating, as like this is kind of like new for for all of you, but for us as well. And I think this is a great opportunity for us to collaborate, and doing streaming data science is relatively new. So we're definitely open to not only your questions but your ideas as well. So feel free to reach out to us.
Absolutely. Thank you everyone so much for making the time. It's like the middle of the summer, there's a heat wave, a lot of people are on vacation. I know that this is a tough time, but I'm so excited for everybody participating, and I hope that we'll see you at the next one. Let's build some momentum around this, okay? And let's change the world together.
Yes, absolutely. So thank you so much for attending the webinar today, and hope to see you soon.